Okay, welcome to the deep dive. Today we're going deep on something that is absolutely critical in the world of software testing. And that's maintaining those automated test scripts you work so hard to create.
It's so important. It can be the difference between a smooth, efficient testing process and just a complete nightmare of constantly fixing broken tests.
Absolutely.
Yeah.
It's like you set out to automate these tests, to save time, right?
Yeah.
That's the whole goal.
That's the idea.
But then if your scripts turn into this jumbled mess, constantly breaking, always needing to be fixed, you end up spending way more time fixing them than you ever saved.
You're fighting against your own tools.
Exactly. And, I've definitely been there.
Oh, yeah.
And it's not a fun place to be. So today's deep dive is all about arming you with practical, actionable best practices. And it's about helping you create test scripts that are flexible.
Yeah.
They don't just break the second something changes.
Right, resilient.
It's exactly. Resilient. They just work reliably every single time.
They just do their job consistently.
Exactly. And the best part, these principles apply across the board.
Absolutely.
It doesn't matter if you're a Selenium fan, if you love Playwright, Cypress, or something else entirely. These ideas are universal.
They're foundational.
Exactly. So, first things first, what does it even mean?
Yeah, good question.
For a test script to be maintainable?
It's not just about passing today.
Right.
It's about how well those scripts are going to hold up weeks, months, even years down the line as your application evolves.
I think it's helpful to look at it through a few different lenses.
Okay.
The first one that comes to mind for me is readability.
Oh, for sure.
A maintainable script, it has to be clear to anyone who looks at it.
Totally.
Whether that's someone on your team or you 6 months from now trying to remember what you were even thinking when you wrote it.
You after too much coffee.
Exactly. Or someone brand new to the project altogether.
Yeah, someone coming in fresh.
Yeah, they should be able to look at the script and immediately understand what it's doing and why.
Absolutely.
And that ties in really closely with the next piece, reusability.
Oh, 100%.
You don't want to have to reinvent the wheel every time you write a new test.
No.
So if you've got a solid piece of code that handles user login, for example.
Right.
You shouldn't need to rewrite that logic in every single test that requires a logged in user.
You're just asking for trouble down the line.
Exactly. And then that sort of naturally leads us to modularity, I think.
Yes, building blocks.
Yeah. Think of your scripts like they're built from these smaller, self-contained modules.
Lego bricks.
Legos. Perfect analogy.
Yeah.
It makes them so much easier to understand.
Oh, yeah.
Much easier to debug when something inevitably goes wrong.
Yeah, you can isolate the problem much faster.
And easier to reuse and kind of, plug into different parts of your overall test suite.
It's about building a system, not just a bunch of one-off scripts.
Right. And then, big one that I think sometimes gets overlooked is stability.
Oh, this is critical.
A truly maintainable script should be able to withstand those inevitable changes that happen in the UI.
Yeah, the layout changes, the button moves.
Yeah, maybe they update, a CSS class or something.
Yeah, you don't want your entire test suite to just crumble because of a minor tweak.
Exactly. And then let's not forget efficiency.
Oh, this is a big one for me.
Right.
Time is precious.
Maintainable scripts, they respect your time.
Yes.
They run quickly without unnecessary delays or complexities.
Nobody wants to wait around for hours for their test suite to finish.
No one. It's funny. I was thinking about this the other day, and it's kind of like having a well-organized cookbook.
Okay, I like this.
Right. If your recipes, your test scripts, are written clearly, broken down into logical steps, and you can reuse certain ingredients or techniques across multiple dishes, anyone can pick it up and get consistent results.
Exactly. Consistency is key.
But if your cookbook is just a mess of scribbled notes, duplicated instructions.
Oh, nightmare.
It's a nightmare.
Yeah.
Trying to follow it or update it is just...
Forget about it.
Forget about it. It's impossible.
And that's what we want to avoid.
Yes, absolutely. So let's get into some specifics here.
Okay, let's do it.
How can we actually write these beautifully maintainable test scripts?
Yeah.
Where do we even begin?
Well, I think a great starting point is something that sounds really simple but has a huge impact.
Okay.
And that's adopting a clear and consistent naming convention.
Naming conventions, yeah.
Yeah, it sounds basic, but trust me, it makes a world of difference.
Yeah. And, I think we've all seen those test functions out there. They're named like test something.
Yeah, or test 1, test 2, test 3.
Right.
Exactly.
What does that tell you?
Nothing.
Nothing. It tells you absolutely nothing about what that test is supposed to do.
You're just left guessing.
Exactly. Now, imagine if you see a test function named, like, test user login with valid credentials.
Oh, that's so much better.
Right. Immediately, even without looking at the code, you know what that test is designed to do.
You can infer its purpose right away.
Exactly.
And it's not just about individual names being descriptive, right?
Right.
It's about the whole team being on the same page.
Okay, consistency, yeah.
Whether you prefer camel case, snake case, or whatever for your variables, stick to it across the entire code base.
I think that's great advice, yeah. One of the things that I've really learned to appreciate in my, time as a software tester is the page object model, the POM.
Oh, yeah, the POM. It's a game changer for UI automation.
It is. Can you give us a quick breakdown for anyone who might not be familiar with it?
Sure. So at its core, POM is about this idea of separation of concerns.
Okay.
You want to clearly separate the logic of your tests, the steps, the flow, from the nitty-gritty details of how you're interacting with the elements on the page.
Right.
So instead of having, lines of code like driver.findElement by .id username, .send keys, test user, sprinkled all over your test scripts.
Which is, by the way, a big no-no.
Yeah, hard-coding locators like that is a recipe for disaster.
Absolutely.
With POM, you create these separate classes called page objects.
Yeah.
Each one represents a specific page or component of your application.
Got it.
And these page objects, they encapsulate all the locators for the elements on that page,
right,
and provide methods for interacting with them.
Okay.
So in your test logic, instead of that messy locator code, you might have something like login page.enter username, test user.
Oh, that's so much cleaner, yeah.
Much cleaner, more readable, and way more maintainable.
And then, the real beauty of this comes into play when, let's say, the ID of that username field changes in a new release of the application.
Right, which happens all the time.
All the time. And if you've hard-coded those locators everywhere, oh man, good luck with that.
You're in for a world of pain. You'll be manually updating hundreds of lines of code.
Exactly. But with POM, you only need to update the locator in one single place in your login page class.
One change, done.
Exactly.
It's a huge time saver, and it makes your tests way more resilient to these kinds of UI changes.
And it kind of, reflects how a user thinks about the app, right?
Yeah, it's like creating a mental model.
Like, okay, I'm on the login page. Now I need to enter my username.
Precisely. It's more intuitive and more maintainable.
All right, so let's move on to another super important aspect of maintainable tests. Keeping test data separate from your test logic.
Oh, this is a pet peeve of mine.
Why is that?
Hard-coding test data directly into your scripts is just bad practice on so many levels.
Yeah, explain that.
First of all, it makes your tests incredibly inflexible.
Okay.
If you want to run the same test with different sets of data, you basically have to duplicate the entire script for each data set.
Right. So, if you're testing different login combinations, you end up with tons of almost identical test cases.
Exactly. And that's just a maintenance nightmare.
I've totally been there, copying and pasting tests and just tweaking the data.
We've all done it.
It seems like a shortcut at the time, but it really comes back to bite you later.
Oh yeah, big time. Plus, when your test data needs to change, good luck finding every single place where it's hard-coded.
Right, it's scattered everywhere.
A much better approach is to store your test data externally.
Okay, so separate files?
Exactly. CSV files, JSON, YAML, even Excel spreadsheets, or pulling data from a database.
Okay, that makes sense.
So, for example, instead of a Python function that looks like, let's say, def test login, admin, password 123, which is hard-coded, you would have something like def test login, username, password, login, username, password.
Okay, so now the username and password are parameters.
Exactly.
That can be fed in from somewhere else.
From your external data source. It makes the test reusable.
And this ties in with data-driven testing, right?
Absolutely. You use these external data sources to drive your tests. And a lot of modern testing frameworks like TestNG for Java, PyTest for Python, Unit for .NET, they all have features for this parameterized testing.
Right.
You write your test logic once, and then you can run it multiple times with different data sets.
It's a huge efficiency boost.
Absolutely.
Now let's talk about assertions. We rely on these to tell us if our tests are actually passing or failing, right?
Absolutely. Assertions are your verification points.
But how do we write assertions that actually contribute to maintainability?
The key is to be clear, specific, and focused.
Okay.
Each assertion should verify one specific outcome.
Got it.
Avoid vague assertions that don't give you enough information when a test fails.
So, like, what would be an example of a bad assertion?
Let's say you have something like assert true element dot is displayed in Java.
Okay, and what's wrong with that?
It tells you that some element is displayed, but it doesn't tell you which element or if its content is correct.
Right, it's not very helpful for debugging.
Exactly. If that test fails, you have to go digging to figure out what went wrong.
So a better assertion would be something like, assert equals element dot get text, welcome user.
Much better. You're specifically checking if the text of a particular element matches welcome user.
So if that fails, you know exactly what the expected outcome was and what the actual outcome was.
Precisely. And this also applies to writing good error messages.
Okay.
When an assertion fails, you want that error message to tell you exactly what went wrong.
So you're not wasting time trying to decipher cryptic messages.
Exactly. Make it easy on yourself and your team.
All right, now let's tackle code duplication. We touched on this with POM and data separation, but what about common actions that users perform in our app?
This is where reusable utility functions come in.
Right, utility functions, yeah.
Think about actions like logging in, navigating to a specific page, submitting a form.
Things that happen in multiple tests.
Exactly. Instead of writing the same code over and over, you create helper methods.
So, like, you might have a function called loginaise admin pass.
Perfect example. All the login logic is encapsulated in that one function.
And then you can just call it from any test that needs a user to be logged in.
Exactly. It keeps your code DRY. Don't repeat yourself.
DRY. I like that.
And it makes maintenance so much easier. If the login process changes, you only need to update that one utility function.
And then, to keep things organized, it's a good idea to group these utility functions into a helper class or a utility class.
Absolutely. Keep your code base clean and well-structured.
Now let's talk about a real pain point for a lot of testers, flaky tests. Those tests that pass sometimes and fail other times for no apparent reason.
Oh, flaky tests, the bane of our existence, often caused by timing issues, especially in web applications.
Makes sense. Web apps can be pretty asynchronous.
Exactly. And a common, but not always ideal, way to try to address this is using sleep statements.
So like pausing the test for a fixed amount of time.
Exactly. But the problem with that, let's say you have something like thread.sleep 5000 in Java. You're forcing the test to wait for 5 seconds, even if the element you're waiting for loads in 1 second.
So it's inefficient.
Very inefficient. And if it takes longer than 5 seconds, your test will still fail.
So it's not a very reliable solution.
Not really. The better way is to use explicit waits.
Explicit waits. Wow.
You tell the framework to wait for a specific condition to be met.
Like an element becoming visible?
Exactly. And you set a maximum timeout.
Got it. So you're not wasting time if the element loads quickly.
Exactly. And you're not failing the test prematurely if it takes a bit longer.
So it's more intelligent and more reliable.
Absolutely. And just to clarify, there's a difference between implicit and explicit waits.
Okay, yeah, I was going to ask you about that.
Implicit waits set a global wait time for all elements.
Okay.
While explicit waits are targeted at specific elements and conditions.
Got it. So explicit waits are usually more reliable, especially for dynamic content.
Exactly. Now, on the flip side, let's talk about some common mistakes that can lead to unmaintainable tests.
Okay. Mistakes to avoid. That's helpful.
For sure. And one of the biggest ones is writing overly complex test scripts.
Complex in what way?
Trying to cover too much in a single test.
Okay.
Keep your tests focused on a single scenario.
Got it. One test, one purpose.
Exactly. It makes them easier to understand, debug, and maintain.
Okay. What else should we watch out for?
Another big mistake is ignoring logging and reporting.
Oh, yeah. That can make debugging a real pain.
It definitely can. Use tools like Allure, Extent Reports, or Log4j to get detailed insights into what your tests are doing and why they're failing.
Makes sense. Good logs and reports can save you hours of frustration.
Absolutely. Another common mistake is relying on brittle locators.
Brittle locators, okay.
Things like complex XPath expressions that are tightly coupled to the structure of your HTML.
And why is that bad?
Because even small changes to the UI can break those locators.
Ah, so your tests start failing, even though the functionality hasn't actually changed.
Exactly. It's better to use more robust locators like stable IDs, well-defined CSS selectors, or custom data attributes.
Okay, so choose your locators wisely.
Precisely. Another thing to avoid is running all your tests sequentially.
Okay, yeah, that can take forever, especially for large test suites.
It can be a huge bottleneck. Use parallel execution features in your testing framework to speed things up.
So run multiple tests at the same time.
Exactly. It'll save you a ton of time. And finally, a mistake that's not specific to testing but applies to all software development. Skipping code reviews.
Code reviews, yeah.
Don't underestimate the value of having another pair of eyes look at your code.
It's like having a second set of checks and balances.
Exactly. They can catch things you missed, suggest improvements, and help ensure that your code is maintainable.
And speaking of help, there are some great tools and frameworks out there to support all these best practices.
Oh yeah, a whole ecosystem of tools.
Let's break it down into some categories.
Sure. First, you've got your automation tools like Selenium, Cypress, Playwright, and Appium for mobile testing. These are the engines that drive your interactions with the application.
Okay, the foundation. Then we have testing frameworks, which provide structure and features for writing and running tests.
Exactly. Things like TestNG, JNet, PyTest, and Cucumber for BDD.
Right. And then we have CI/CD tools like Jenkins, GitHub Actions, and Azure DevOps.
These automate your testing process as part of your software delivery pipeline.
And finally, code review and collaboration tools like Git, Bitbucket, and code linting tools.
All essential for maintaining a healthy code base.
All right, so let's quickly recap the key takeaways here.
Sounds good.
Maintainability really boils down to readability, reusability, and stability.
And to achieve those, remember to implement the key best practices: POM, reusable utilities, and data separation.
And just as importantly, avoid those common pitfalls like hard coding, complex scripts, and neglecting logging and reporting.
Choose the right tools and frameworks, and you'll be well on your way to building a robust and maintainable test automation suite.
So for you, the listener, here's a little challenge to take away.
Okay, hit us with it.
Think about your current test automation process. What's one area that could benefit most from these practices?
Yeah, be specific.
And what's one concrete step you can take right now to make that area more maintainable?
Start small, but start today.
Exactly. How can you save yourself some time and headaches in the long run?
It's worth the investment.
Thanks for joining us on The Deep Dive.
It's been a pleasure.
See you next time.